Okay, so I think you can see that. So just to remind you, we're doing chapter 7. We're doing where things aren't moving. This is we're modeling with things that are static. Okay, so what my plan is, there's only a couple of examples, but it's quite a big exercise. So we're going to have today's lesson and the next lesson to try and work our way through these. So example 3. Okay, so just picture what's going on here. We've got a smooth bead, Y, and it's threaded on a light extensible string. Okay, so this string isn't moving. So just picture what's going on. So the string is attached to the ceiling at X and Z. Okay, so there's a bit of, so the string's going down through the bead, and you need that 8 Newton force to the left just to keep the Y immediately below X. So just try and envisage it. Okay, you've got a bit of thread, you put a little bead on it, it's attached to the ceiling at X and Z, and to keep it in that shape, you're just pulling a bit to the left. Now the key thing here is, because the bead is threaded, it's automatically going to make the tension on the 2 strings the same. So can you see to the right where I've just blown up the diagram? Because it is threaded, you can assume those 2 tensions are the same. It would be different if there was 2 pieces of string properly attached to the bead. They could then be under different tensions, but because it's threaded, everything sort of evens itself out. Okay, so the key learning point from example 3 is that you've reduced the number of unknowns because the tension upwards on the upward bit of string is the same as the tension going off to the right. Okay, so we've then only got W and a single T as our unknowns. You can see on the right that I've just only had to break down that 1 tension until the 2 green bits to make everything either horizontal or vertical. And then it's the usual, just resolving in either direction. F equals MA. We are not accelerating, so our forces all cancel each other out. Okay, now I'm choosing to resolve horizontally first because T is my only unknown there. Okay, I'm resolving horizontally because W is perpendicular, so that doesn't come into play. So by resolving horizontally first, my right hand force, T cos 30, equals my left hand force, V8, so I can work out what tension is. And then when I resolve vertically, I now know what tension is, so that allows me to work out what W is. Okay, so the key thing to take away from this example, exam technique, you go and see it say the word threaded, okay, you immediately can go and make those 2 tensions equal to each other. So that's all I want you to take away from example 3. Now, example 4, just wait for it to click through. There we go. So a classic pulley question. Okay, so let's just see what's going on. We've got a mass of 3 kilograms resting on the surface. It's going over the pulley and coming downwards. We're told it's at 45 degrees. It's a smooth pulley, so there's no friction involved. We'll come on to that later this chapter. And then just have a look. I didn't blow this one up, but just look at the one on the left, just to make sure that you can appreciate all the forces in play. So that little diagram on the left, obviously the mass has got the weight going down of 3G. We're told that the mass of the other weight is 1 kilogram, so that's the 1G. The key bit again is the bit I've done in green in the diagram. Those 2 tensions are equal and opposite always going over that pulley. Okay, actually I've confused things here a bit. That's the smooth pulley means therefore there is no friction. That's a standalone point. So I'm just going to change the colour where I've said smooth pulley. Okay, the bit in green is the second point. So the fact it's smooth means no friction in your diagram. But whenever you have one of these pulley questions, start off by getting those 2 tensions either side of the pulley, both the arrows pointing at the pulley, and those 2 tensions will be equal to each other. So again, those tensions are equal. And then start off, you can see I've extracted it to the bit over on the right, just look at it from the point of view of the 1 kilogram mass, which is just coming over the end of coming over it. That's, you can look at that in isolation, and that straight away tells you that the tension equals the weight. Okay, so tension equals the weight. So just by focusing the bit on the right, you can then go back and focus on the 3 kilogram mass and just sort of work your way through, as I've said there. So what have I said? So we've got 2 unknowns. We don't know P, we don't know R. By choosing to resolve diagonally up the plane, R does not come into play. Okay, so by starting off by resolving diagonally up the plane, that allows us to work out what P is, and then step 3, you can then work out what the normal reaction is, because that's then your only unknown. So your choice whether you want to properly copy that one out, or you just want to start practicing the questions. So to conclude, the key bit to take away from example 4, it's smooth, so don't worry about friction. Whenever you've got a pulley in play, just make those 2 tensions either side of the pulley. The 2 arrows are pointing at the pulley, and those 2 tensions are equal to each other. They are both T. So I think that's really all I wanted. Yes, we're then into exercise 7B. I think I'd like us to do this from the beginning, please. I think it just requires a bit of getting used to these. So I'll stop the recording now, and then obviously I'll keep this screen split so I can help you with these questions.